Hello student, welcome to your chemistry lab. Today I am discussing reaction mechanism part 11 of organic chemistry. Today I will discussing the free radical addition reaction. We are discussing in previous class electrophilic addition reaction, nucleophilic addition reaction, and last is free radical addition reaction. It is important for JEE and NEET, so read very carefully. So now we are watching the whiteboard. Free radical addition reaction. Alkenes and alkynes undergo free radical addition in presence of peroxide. Here peroxide is used, not hydrogen peroxide. Here peroxide is used benzoyl peroxide. Means peroxide dissociate into free radical which colloid with the molecule of alkene or alkynes and initiate a free radical addition reaction. And the first example, propene react with HBr in presence of peroxide, that is the benzoyl peroxide, gives 1 bromopropane. And next example, styrene react with HBr in presence of peroxide gives 1 bromo 2-phenyl ethane. The ratio selectivity of addition to an unsymmetrical alkene is different from the addition of HBr without added light, heat or peroxide. In this example, propene first react HBr in absence of peroxide gives 2 bromopropane and presence of peroxide gives 1 bromopropane. HBr addition to propene without added light, heat or peroxide gives 2 bromopropane. The hydrogen atom is added to less substituted carbon and this reaction occur via carbocation interview. And HBr addition to propene with added light, heat or peroxide gives 1 bromopropane. The Br atom is added to the less substituted carbon. This reaction occur via free radical intermediate. Mechanism. Chain initiation. First benzoyl peroxide gives that compound which is formed by the homolytic cleavage of peroxide linkage in benzoyl peroxide and gives C6H5 dot. And second step, C6H5 dot react with HBr, form C6H6 and Br dot. Third step, chain propagation. Here first Br dot react with propene. Here propene is marked as a C1 and C2 carbon in CC double bond. First Br dot react in C1 carbon, form 2-degree radical, and second Br dot react at C2 carbon, form 1-degree radical. We know that 2-degree radical is more stable and 1-degree radical is less stable. And second step, HBr added gives the major product, and more stable radical means stable intermediate step gives major product and less stable intermediate gives minor product. Major product is formed from 2-degree radical since it is more stable than 1-degree radical. Hence, the product obtained is anti-Markovnikov addition product. What is anti-Markovnikov rule? When unsymmetrical alkene undergoes addition with HBr in presence of peroxide, the product form is anti-Markovnikov product. Hydrogen connect to the CC double bond holding less number of hydrogen atom and Br connect to the CC double bond holding more number of hydrogen atom. This is the anti-Markovnikov rule. But HCl and HI do not show peroxide effect. Radical chain reaction are successful when propagation step is exothermic. An endothermic propagation step, that is del H is positive, is reversible and would break the chain. With HI, first propagation step is endothermic because the HI bond is weak. With HCl, second propagation step is endothermic because the HCl bond is strong. Consequently, HCl and HI do not show the peroxide effect. With the HBr, both the propagation steps are exothermic and HBr added the double bond by free radical mechanism. Alternatively, HCl bond is stronger, that is 430.5 kJ per mole, and then HBr bond, that is 363.7 kJ per mole, is not cleaved by the free radical, whereas HI bond is weaker, that is 296.8 kJ per mole, but iodine free radical combine to form I2 by instead of adding the double bond. If the addition of HBr take place to unsymmetrical alkyne in presence of peroxide, that is the anti-Markovnikov product is formed, and this example propyne react with HBr in presence of peroxide gives 1 bromo prop 1 in. So thank you. I think you are enjoying to watch my video. I think you are understanding the free radical addition reaction and also clear all the point. If are not clear, so comment me, I will reply you. I will be coming with next part of reaction mechanism of organic chemistry. So thank you everyone. Bye.